Now I'm going to introduce you to trigonometric integration. So we will be integrating the likes of sine squared or cosine to the power of 3, or the mixture of the two, sine squared cos to the power of 4, or the likes of this, or 10x secant squared of x. Now if you don't know this, I will explain this in the future, but similar to this, you will have cotangent of x, and you have cosecant of x. Well, I will explain these in the future, okay? And then we will try and integrate something like this as well. But to start off with, let me show you something simple like this one here. How would you go about integrating this? You've got one block multiplying another block. So, when it comes to trigonometric integration, try to look for this. Write it in this form here. Hang on. Always try and keep an eye out for this, something being the exact derivative of another thing. If you look at this block here, cos is the exact derivative of sine. So whenever you get this scenario where you got one thing is exact or near enough to the exact derivative of this thing, then you know you can use u substitution. So using u substitution, well, here you've got one thing multiplying another thing. If you can recognize that this thing is a derivative of this thing, then use substitution. Use u substitution. So let u equal sine of x. So later on we can put this u into here. So that will then become this. And then well, if you let u equal sine of x, then du, well, if you differentiate this side and then differentiate this side, differentiate this, you will have cos, and then you've got your dx here. And now you want to get dx on its own because of this bit here. If you get dx on its own, then later we can put this into here. So putting this into here, that will then give us this, and then put this u into here. That will then give us this, and then you've got this block staying the same. So now this will cancel out with this. That's the whole point of us looking for this. We're always trying to get this thing being the derivative of this thing, because this will cancel out with this thing here later on. Well, I hope you can see that this thing here will cancel out with this. So when it comes to trigonometric integration, always keep an eye out for something like this. Always, because once you recognize that this is the exact derivative of this, then you can just use u substitution. It would be really easy to use u substitution. Well, anyway, this will cancel out with this. That will then give you this, and then just integrate this. That will then give you this, and then what is u? Well, u is this thing here. So we will put this back into the u. That will then give us this. So when you integrate this, it will give you this, and if you differentiate this, so hang on, so let's rewrite this as this. Let's try and differentiate it to make sure. So wait, I'm going to visualize it like this, to the power of a half, to the power of 2. So when you differentiate this power will come down, so that will become 2 over 2. The bubble stays intact. And then the power gets minus by 1. Power gets minus by 1. Oh, no, it gets minus by 1. So so this thing here, and then you times the derivative of the bubble itself, which will be cos of x. So this thing here is exactly the same as this. But when you come to do this, forget about u substitution, because this is quite simple. Because excuse me, because this is quite simple. If you can recognize that if you can recognize that this thing here, if you can recognize that this thing here is the exact derivative of this thing here, then don't bother with u substitution. Just guess. Looking at this, just guess. You're looking for something in such a way that when you differentiate it, it will give you this. Well, you should make this to be your initial guess. It's got to be one notch higher than this. So guess this. Make this to be your initial guess, and then when you differentiate this, the 2 will come down, So that will be 2. The bubble stays intact. The power gets minused by 1, which is 1, and then you times the derivative of the bubble itself, which will be cos of x. So you can see that this thing here is very similar to this, but you've got this 2 here. So you would then go back to here, and then try and negate this 2. So stick a half in here. Now when you differentiate this now with that half, this 2 won't be there. So now, the point I'm trying to make is that this is quite simple when you glance at it. So make your initial guess rather than using U substitution. Just guess. After a while, you get used to it, and then you can do it straight away. Make this to be your initial guess, and then differentiate it and so on. Well, your final answer will be this thing here. Okay. I will give you more examples in the next video.